Okay, geometry, let's continue on with our 5 notes here. I got a couple good example problems involving HL. All right, so this first one here says Ashton is washing windows using a 10-foot ladder. For the first window, the ladder reaches the window when he places the base of the ladder at the rose bush. How can he determine where to place the ladder to be sure it reaches the last window? Okay, so this is sort of a thinking question, right? So again, you want to determine where I should put the ladder here, right? So pretend I'm scooting the ladder down this way, right? So here's where the ladder's going to go. And again, you have this right triangle that is formed. And again, the ladder does not change length, so it's still 10 foot no matter what. Okay, so let's make a couple observations. So first, the ladder will remain 10 feet long. Will remain 10 feet long. If you look at these right triangles here, the ladder is the hypotenuse of the right triangle. So you're going to have congruent hypotenuses wherever you put your ladder, right? Okay. And the house is assumed perpendicular to the ground. Right, so as you can see when I drew that second right triangle, I put the right angle there where the house meets the ground. So therefore you have right triangles. So how can you be sure that the ladder is going to reach the last window? Well, we want to make sure it reaches the same height as the first triangle, right? We want to make sure that this vertical leg is the same as that vertical leg. So we have congruent hypotenuses in right triangles. We need a pair of congruent legs. So here's the kicker. So if you make sure you place the base, so you make sure you place the base of the ladder the same distance away so that's assuring that this bottom leg is congruent to this bottom leg, right? So you have a pair of congruent legs. Then the height of the ladder will be the same. And again, the reason is if you have congruent hypotenuses, right, in right triangles and congruent legs, then you can use HL to say the triangles are congruent. And if the triangles are congruent, then all of its corresponding parts are congruent. So we can use CP, CTC to show that those vertical sides would also be congruent. All right, so this is sort of like thinking about a proof, just applying it to a real life situation. Did someone mention proof? All right, let's take a look at the next one. Uh-oh. Whoa, boy. Okay, so we're going to write this proof. All right, it's going to involve HL. Now, this is not a simple proof, so let's talk about it. So we are given a lot of information. We're given FD perpendicular to AB. So right now, where's FD? Where's AB? Notice that they have the right triangle drawn. The right angle drawn, right? That's what it means to be perpendicular, and it's on both sides. FE is perpendicular to AC. Again, over here, right angle. We know that AE is congruent to AD. Now, AE and ED are only in these top triangles, so be aware of that, right? And then FC is congruent to FB. Now, FC and FB are in the bottom small triangles, and also if you look, this AF separates the big triangle into two triangles. CF is also the bottom of the big triangle on each side, and FB on the other. So we need to prove that triangle ABC is isosceles. ABC is the big triangle. So we need to prove that it is isosceles. So I believe our goal here is going to be to prove that AC and AB are congruent. If we can prove that segment AC is congruent to segment AB, right, then we can prove that this triangle is isosceles. So that's our goal, right? So it'd be nice if we could prove that these two triangles are congruent and then move from there. Let's see. So let's always start with our given. And you're going to see me, I'm going to have to like erase my writing here a little bit. So number one, because it's a long proof, I don't have enough room. Okay, so number one here, we were given that segment FD is perpendicular to AB. We were given that segment FE is perpendicular to AC. We were given that AE is congruent to AD. And we were given that FC is congruent to FB. Right, that was all given to us. And we marked it together up there. So I am going to focus on these top two triangles first. Okay, so we know that triangle, or not triangle, angle AEF and angle ADF are right angles. Right angles. That's the angles apostrophe S. And that is by the definition of perpendicular lines. Again, you'll see me use a lot of shorthand when I do these proofs. So we've established that triangle AEF and triangle ADF are right triangles. And that is by the definition of a right triangle. A right triangle has to have a right angle, right? So there we go. So in these two right triangles, AE and AD, those are legs, right? So these two triangles at the top here, can we prove that the hypotenuses are congruent? Well, the hypotenuse of these top two triangles is AF, the shared side. So segment AF is congruent to itself. I believe if you recall, we did that in, I think it was the angle side angle section. This is the reflexive property. And there's your hypotenuses. And now we can prove that triangle AEF is congruent to triangle ADF, and that is by HL congruence. And we're there, right? So now, why would we do that? Why would we prove that these two triangles are congruent? Well, I think that part of this proof, and to prove it's isosceles, we also have to prove that these bottom two triangles are congruent. So what this does for us is it gives us another pair of congruent things in those two triangles, right? It gives us EF and DF, right? EF and DF are corresponding sides in these top two triangles. Because these top two triangles are congruent, EF, use 4, and DF will also be congruent. So this is going to be a step 6. Segment EF is congruent to segment DF, and that's by CP/CTC. Okay, so we're halfway there. All right. Now I'm going to actually erase some of the stuff. Okay, and we're going to focus on these bottom two triangles now. All right. So let me clear. I apologize. Actually, let me just erase the bottom here. Right. Let's see how this works. Yeah, I don't want to clear the screen. We're halfway done, right? I think this is a 12-step proof, so we're done with step 6. Okay. So now, if I focus on these bottom 2 triangles, so we just showed that EF and DF are congruent. That's a pair of legs. Okay. Now, I mentioned that when you have perpendicular lines, right, either side is a right angle. So let's use that again. So let's say that angle, and let's call it CEF, and angle BDF are right angles. And again, that's going to be by the definition of perpendicular lines, the same perpendicular lines we used above in step 2, right? It's these 2. But now we've established that these bottom 2 triangles are now right triangles. So triangle CEF and triangle BDF, I apologize, BDF, just using the same lettering as the angle above, are right triangles. And that again is by the definition of right triangle. It has a right angle. So these 2 angles are also right angles. I'll do that. I'm going to do that in blue here. No, I'm going to do it in green. I should have continued in green. Sorry. And now CF and BF were given to us as congruent. They're now the hypotenuses of these 2 bottom right triangles. We now can use HL on these bottom 2 triangles. We now know that triangle CEF is congruent to triangle BDF. And that is by HL congruence. Now, there's a couple ways we can go about this. I think the simplest way is, and I'll use blue now, in an isosceles triangle, if you recall, right, isosceles triangle, you have a pair of congruent sides. You also have a pair of congruent angles. So I believe that now that these 2 triangles are congruent, I believe we can say that angle C and angle B are congruent. Angle C is congruent to angle B because those are corresponding angles and the triangles are congruent. Corresponding parts of congruent triangles are congruent. And now because those base angles are congruent, we can now say that segment AC is congruent to segment AB. This is this was the converse to the isosceles triangle theorem. The isosceles triangle theorem said if you have 2 sides congruent, then you have 2 angles congruent. The converse says if you have the base angles congruent, then the opposite sides. And if segment AC, all the way down here, and segment AB are congruent, then yes, triangle ABC is isosceles. So number 12, triangle ABC is isosceles. And that is the definition of an isosceles triangle. Woohoo! Look at that fun proof. Didn't you have a good time doing that, right? So I have been doing proofs for many, many, many years. So I knew the game plan going in. Again, I know that they wanted to use HL, and I knew what it meant to be isosceles, right? So the more proofs you do, the better. Hopefully your practice involves some really interesting proofs. All right, thanks for watching. We'll see you during class.